Hello everyone, welcome to the past paper discussion. In this video, we are going to discuss 15th question of this particular series. Let's get started. An electrical circuit contains a capacitor. The charge on the capacitor is Q coulombs at time t seconds. This satisfies the differential equations, which is given d square q by dt square plus 5 dq by dt plus 20q equals 200. And initially, Q is 1, dQ by dt is 8. Using Euler's method by taking H is equal to 0.1, we have to estimate maximum charge on the capacitor during the first second, right? Simple question, let's get into this. So this is the formula available in the booklet related to this. It's a coupled linear system of that is differential equations, right? Okay. But before getting into the calculation, we have to make sure it is in linear form. But here I have like degree 2. So let's work on it first. Like converting this into linear form, like degree 1 form. So take that and give some substitution. dq by dt, if I make it y, then yeah, we can able to reduce it. dq by dt equal 1. Sorry, y something. So y is better, easy to connect. Then what is d square y by d square q by dt square? That also should be replaced, right? So it is nothing but d by dt of dq by dt, which is d by dt of dq by dt have changed to y. Simply dy by dt. So now we have this d square q by dt square should be replaced with dy by dt. That's it. Now we are going to apply the changes. First d square q by dt, which is dy by dt. Then I got plus 5 dq by dt, which is y, 5y. Then plus 20q as it is, 200 as it is. Now make it dy by dt equal 200 minus 20q minus 5y. Okay. We convert, this is a function of q1y. Got it? Now, initial conditions. Initial conditions, time initially it's not given, but actually it's 0. T naught you can mention. Charge initially it's given, it's 1. Rate of charge dq by dt is 8, which means now I have changed the name, right? dq by dt means it's y. Here you see. So it's better to write. Let's keep this and y naught. It's not wrong, but y naught is equal to 8. Okay, right. Then the change, and we know the coupled Euler's method formulae. Let's take this. It is available in our formula booklet too. You can refer it. Okay, so here they have given in this form, xn plus 1 is xn plus h times of this. Yn plus 1 is yn plus h times of this. Okay, so using calculator, we can easily do one thing. Let's make a formula for Tn. Okay, so h is 0.1. So the next time 1 will be 0.1, 0.2. In that way, it will increase. So next, if you want Tn, the previous time means n minus 1th time plus h. Some of you might have studied dx. That is also correct. H is dx. This is one of the easy way. Same formula, but we are making it easy. Now, next I have q naught, not x. So let's change the formula in that way. Okay, here it's better to change, or h is fine. Then q naught. Okay, how to find q1? The previous charge plus yn minus 1. This y value, right? The charge, the change, times the change, that is h. Okay. And now the next part is Tn, Qn, Yn. So how to find this Yn? The previous y value plus f of qy, the respective qn minus 1, yn minus 1, the respective stuff, times the h. So these are the three formula. We are not going to, we can use the calculator directly over here. So, but this is how we have to structure it out. When you're calculating also, you should get, okay, what's the formula, correct? Now, let's move into the calculator page now to continue. Okay. Right. So let's take a spreadsheet. Okay, what are the things we have? We have T, we have Q, we have Y, and change is also there. Like f of q, that stuff I'm naming it as a change. Then you can take a calculator and then define the functions. Like whenever h comes, you want to give it 0.1 there. Okay, so define, either you can use semicolon and equal, and what you want to define it 0.1. It results 0.1 means it's stored. I have to save a function also. F of q comma y is what I got. I need to define it, which is f of q comma y, and we need to define this, so semicolon and an equal, or you can use control and this also, it will insert it. Okay, what is my, it's 200 minus 20q minus 5y, and it is defined, right? Okay, now back to the spreadsheet. Let's go with initial condition. Time is 0, charge is 1, y means dq by dt, that is actually 8. This is nothing but, you can even change it like fq, sorry, we define it as f of p comma q, sorry, q comma y, that way. Okay, since it's a function, it doesn't accept, so any f qy will be fine. So to get an understanding, I need to find this f of qy when q is 1, y is 8, and under this constant. So we won't solve it manually. If you want the calculator to solve the part, just start with an equal sign. Equal f of q comma y, but what is your q value? 0, comma, okay, again you have to go inside, put a comma, then y value. That's it. And go out and enter. So now let me reduce the size. We got this, right? And next one, next t will be 0.1, 0.2. This also no need to do manual. So make a formula, the cap equal to the previous t value. So just click on it, plus I need to add a h. We defined it as h, right? H is 0.1. So it got. And you can just drag it from the, once you got the plus cursor, right? And all the same formula will applicable for every cell. You are just dragging it out. Okay, till 1, first to second, right? We are break, yeah, till this. And 1, you should not drag it. We have to derive the, like, define the formula over here. So what is Q formula? If you want the a particular charge at that moment, Qn is the previous charge plus previous y value, that is change in charge, times that h. Okay, so let's do it. Equals previous charge plus previous y value, go again, times h. Everything should be defined. So we got a 1.8. And you can just drag it. But here there will be a problem. It will show you blank because it depends upon the previous y value. Y value is not filled, right? But you can just drag it. Once we start feeding in the values, it will give the blanks will change to values. Let's see. Now here I want to solve. What is yn? If you want dq by dt at the n second, that particular moment. So yn equal to the previous y value plus f of the previous f of qy, qn minus 1, yn minus 1 times h. So equals this and go plus then previous this times h. So we got a 22 here. Right? And this one is again equal this. Okay, I think this you can drag it because we already applied the formula here. Just drag it. And you drag it over here. Here also one value got filled, but the other doesn't. No problem. Let's just drag till 1. Okay. And move on here and drag this stuff. See, it got filling up. Because all of them depends upon this change, right? Okay, actually this is not. So till 1 we have solved it. Okay, now coming back to the question, I have used the Euler method and everything we have did it correctly. Now the actual question is the maximum charge we need to find, correct? The question says, using Euler's method, estimate the maximum charge on the capacitor during the first second. The first second is breakdown in this particular width, right? 0.1 interval. And just analyze the Q is the charge, 1.86 point. So just go through the values, 12.3, 12.6. Okay, 12.6 is the highest we can see here. And it is attained at 0.7 second. That's it. So let me take this. Wait a minute. I'm just focusing on this part. That's simple. We have solved it. Right? Now switching to the solution page. From the work we have did, just show your work like this. And we got the maximum as 12.76. It is attained at t. T equals 0.7. Maximum charge is 12.6 coulombs. Got it? That's simple. And that's simple. The problem is over. Yeah, I hope this might be clear to you. And thank you so much for listening with us. Let's meet in the next video.